Okay, people. So, stoichiometry calculations involving molar concentration. What is molar or molar? Whoa, that's a big font. What's molarity or molar? So molarity, and it equals moles per liter. And remember, it's capital M for molarity. And the fancy way they do it, I don't know if it's fancy, they use square brackets to represent concentration. So if something says concentration, that's molarity, which is moles per liter. Because what unit do we always want in chemistry to compare things? Moles. Moles is like the what?
Magic wand.
The magic wand. Thank you, Enya. All right. So, let's just go down here. Consider the equation for the reaction when you swallow Tums. Do we eat a lot of Tums? Yeah. Because heartburn, do you know what heartburn is? It's not really anything to do with your heart. It's just when you get acid reflux, so your stomach acid comes up into your, what do you call this thing, people? Esophagus. Thank you, esophagus, and you get a burning sensation. All right, that's all heartburn is. So Tums is calcium carbonate. Your stomach acid is hydrochloric acid, and it. You know that?
I didn't know what it was, but
it's hydrochloric acid. So you neutralize it by forming calcium chloride, CO2. That's why you burp, and water. Why not? Well, there is other stuff in your stomach. No, because there's a line. Are people in biology here?
no.
Oh, it's by 11. By 11, you don't learn this stuff, right?
By 11 is like
There's a lining on your stomach, like a mucose membrane that protects it. And so an ulcer is when, well, don't quote me on this. I can't remember this. But there's bacteria that causes an ulcer, but also like it's a hole in your stomach. It's like you burn a hole, right? So anyway. Sorry? The bacteria is H. pylori, Helicobacter pylori. I think that's what it's called. You can look it up, but I have a biochem degree, but I forget a lot of that. I'm focused on the chem, not the bio. All right. Okay, so it's not strong. It's not concentrated, right? You don't have like 1 molar. Actually, I don't know what the. Let's look it up. Hang on. Stopping the video. All right, peoples, we're back. We concluded that the concentration of stomach acid was 0.16 for those of you. Oh, there it is right there on your screen. Have a nice day. All right, here we go. Tablet of Tums, calcium carbonate, has a mass of 0.75 grams. What volume of stomach acid having a concentration of 0.001 molar? This seems to be differ from what the internet said. Is the internet not always true? Or is this not true?
No, the internet's always true.
The internet's always true. Okay. All right. What volume of stomach acid having a concentration of 0.001 is neutralized by 1 tablet of Tums?
Why'd you say it like you're in an ad?
Maybe I'm sponsored by Tums, and I'm promoting Tums in the classroom. You're all going to run out and buy Tums, and I get a percentage of those sales. Okay. Okay. What are we doing? I don't even know what we're doing. Has a mass of this. What volume of stomach acid would be neutralized by that? Okay. What do you want to do? What are we given? Like, you're given something. When we're doing stoichiometry, you're given something. And when we do our little thingies, usually have a number that starts everything off. What number should be in that corner?
Like 0.0010 molar hydrochloric acid.
Well, they're asking how much can 1 tablet neutralize? They're essentially saying I've given you 0.75 grams of calcium carbonate, right? By saying 1 tablet. So that's going to go boop, right in the corner there. Oh, what did we not do that we should have done? You got to look at the balanced equation.
Are you gonna try to trick us? Are you gonna put a equation?
No, if I want you to balance the equation, they will all be blank. Okay, and I'll say balance the equation first.
Okay.
I won't give you one that has numbers in it and say, just use this, and then you have to. Is it balanced or is it not balanced? I will not do that. Okay. Except for maybe Carter. All right. He didn't even. He's not even listening. All right, so we can assume the equation is balanced.
It's balanced.
0.750 grams of calcium carbonate. Do we like grams? No, we got to convert it to moles. So what's the molar mass of calcium carbonate? 100.1. It is. Good job. So 1 mole of CaCO3 is 100.1 grams of CaCO3. Okay. All right, so now we have moles of calcium carbonate because our grams all cancel. So now we're at what point in our little flow diagram? The mole bridge. Everybody's favorite. When you're crossing the mole bridge, what do you use? Did you say moles?
What?
You need to go to the equation, right? Because you need the ratios. So we have calcium carbonate, and we're trying to figure out what's the other mole thing that we're using? HCl, right? So we know 1 mole of CaCO3 is 2 moles of HCl. Okay, so now we got moles of HCl. Do they want the answer in moles? What do they want the answer in?
Molarity.
Volume. They want the answer in volume. They want to know. They want to know how much. Like how much. All right. So they give us the concentration. Now, concentration is what? Moles over liters, right? So this number, 0.01 means, or 0.001, whoops, moles per liter, right? Okay. What unit do I want in the bottom here? Moles, right? So that means it's going to be 0.001 moles in 1 liter. Does that make sense? So then you cancel. You always check with the calculations. Like, do all the units cancel, and what are you left with? We're left with liters. So you multiply everything on the top, and you divide by the bottom. I need you to do this on your calculator because people will always mess up the actual calculation. They can set it up, but then they box the calculation. So please get your calculator out. How many sig figs should we have?
3.
Yes. What's the answer?
15.0 liters of HCl.
15.0? Is that what people got? Yeah? Okay. Can we flip the page? Oh, what volume of CO2 at STP is produced if 1.25 liters or 0.00055 molar HCl reacts with an excess of CaCO3? Okay, if you see the word excess next to one of the reactants, you don't even have to worry about it. It means it's basically unlimited. You're never going to run out of it. Okay? So the limiting would be the HCl. Okay? So you don't even, as soon as you see the word excess, you can just be like, we don't need to worry about that one. There's enough to react. Okay, what volume of CO2 is produced if 1.25 liters of blah, 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 blah? Okay, So this is what we're given. 1.25 liters of 0.0055 molar HCl. Do we like liters? No, we always want moles. So if I know the liters and I know the concentration, can you find the moles?
Yes.
So we can go. What do I want to do here? Let's go. Molarity is moles per liter. I know the molarity is 0.0055 molar. Moles, we don't know. The liters is 1.25 liters. How do I get moles out of that? Multiply the 1.25 up. Spits out. What does that spit out? All right, I'm going to write it in scientific. 6.875 times 10 to the minus 3 moles of HCl.
Are we keeping all those secrets?
We're going to keep them till the end. We'll use these, or we'll use this to do our thing. But okay, so that's our starting point. We have this many moles of HCl. How much CO2? What is the question asking? How much CO2 will we get? Okay, so we get 6.875 times 10 to the minus 3 moles of HCl. We're at moles. So what are we crossing? The mole bridge. Aren't we all excited to go across the mole bridge? What if it collapses one day? All right, so for every 2 moles of HCl, we produce 1 mole of CO2. Yes? 2 to 1. You just take it right out of the equation. So 2 moles of HCl produces 1 mole of CO2. They want to know volume. If you're doing volume of a gas, what's the conversion factor? 22.4 liters per mole. Cancel, 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 cancel. And then you're going to do the calculation and tell me the answer.
0.077 liters of CO2.
What? Give me all of the decimals.
That is all of this.
0.07.
7.
That's it?
That's it.
Yeah.
Oh, okay. And does that line up for the right amount of sig figs?
Yeah.
It does, because you have to go back to the beginning, right? This has 2 sig figs. That has 3. So we know their answer has to have 2. So 0.077 liters of CO2.
So we just added molarity to the.
You just added an extra step, molarity. That's all we've been doing. First, it was just moles to moles. And then we did grams to moles to whatever. And now we're just doing molarity to moles to whatever. Right? This is Stoich. Okay. All right. I gotta stop the thingy.